In this recording, we'll be showing you how to work with dynamic diameter, and we'll also show you how to work on edges such as this, where they come into close contact with the actual wall over there, and how we avoid gouging the wall. Okay, let's first go into dynamic cutting diameter. You'll note that if we use dynamic cutting diameter, compensation cannot be used. Click it. You see there's no compensation. Now, dynamic cutting diameter allows you to vary the point of contact of your tool according to the diameter of the tool. This is a 4mm chamfering tool, so I'm going to allow that the contact area be anywhere between 1 and, say, 3.5. That means that as it's going around the part, the diameter of contact to the geometry will vary between 1 and 3.5 millimeters. Let's take a look at the simulation after I do save and calculate, and you'll see the follows. The tool, now do this one step at a time, will go down. If we take a look at the side view of the part, you'll see that we're starting at 1 millimeter, and as we're going along, you see that's going to go further and further away from the edge itself. You can see that changing, and it also went further down. However, the actual chamfer stays the same. Let's take a look at this at Solid Verify, and you'll see that the chamfer size remains the same all around the part. Now let's take a look at a new operation. So I'll do save and copy, and how it works with a different geometry over here. I'll create a new geometry. I'm just going to add the option of up to entity, and I'm going to do the following. I'm going to click on this edge, and up to entity, this edge over here. And I'll accept that. That means it's working on this edge over here to put a chamfer on that. I can do the same thing with the flip side. So I'll do this edge up until this entity and accept that as well. I'm going to be using the same chamfer mill. The levels, my upper level this time is going to be over here, this surface. And again, I want this at 0.2 millimeters as far as the depth of my chamfer. This time my technology, I'm going to keep it at constant diameter. I'm going to have that at a 3.5 millimeter diameter. Now remember that in my geometry, I do have my target protection turned on. And this is very important in this particular case. And I'm also giving it a 0.1 millimeter offset, so it should stay at least 0.1 millimeters away from the target. We'll run our simulation, and we'll see the follows. The tool will go down, and you can see it's going down away from the part. Let's take a look at the top, away from the wall, and it's not starting exactly on this edge, but it's starting a way that it does not touch the model itself, and it's going on this corner. As it goes down, it'll form an edge on the corner without gouging the part. Let's take a look at the Solid Verify, and you'll see the exact same thing. The tool will go down, away from the part, and you can see that there are no gouge marks on the wall itself. This concludes our series of our chamfer operation.